Hello everyone, my name is Isabel Tu Yuan Yi from DCE 2A, and today I'm going to do a tensile test on mild steel. This test involves training a test piece by tensile force generally to fracture for the purpose of determining one or more of the mechanical properties. The objective of this test is to study the mechanical properties of mild steel specimen under tension load. Step 1. Measure the initial diameter of the tension test sample in two perpendicular directions using vernier caliper. Step 2. Measure the length of the specimen between the grips by using a scale. After measuring, the length of the specimen between the grips is 192 mm. Step 3. Punch marks are made at a distance of 2.5. Step 4. Insert the specimen into its position and mount extensometer on the specimen. Step 5. Readings on the dials A and B of the extensometer are adjusted to 0. Step 6. The experiment is conducted. Load extensometer readings are read at regular intervals of load up to the yield point. Ivory scales reading are noted till the specimen failure. So this is the graph, load versus ivory scale reading graph. And next we have load versus extensometer reading graph, and the slope of the graph is 2.27. Step 9. Join two pieces of the test sample and measure the diameter at the neck of the specimen, and the final diameter is 7.86 mm. Step 10 is to measure the final length between three punch marks. So the final length between the punch mark is 85 mm. So this is our observation, and this is the graph. So first of all, we have yield stress. The formula for yield stress is yield stress point over AO. And from the graph, we get that the yield stress point is 43 kilo and the AO is 129.02. So we take 43 kilo divide by 129.02, we will get 333.28. Next we have tensile strength. Formula for tensile strength is ultimate load, which is the highest point in the graph, divided by AO. So as you can see, the highest point in the graph is 49. So 49 kilo divided by AO is 129.02. And then we will get the answer for tensile strength is 379.78. We have modulus of elasticity. The formula for modulus of elasticity is slope times 1 over LC times gauge length over AO. So the final answer for modulus of elasticity is 211.13. Next, percentage elongation. For the formula, we need to take final length minus punch mark times 2 over punch mark times 2 and then times 100. So based on the observations given, the final length is 85 and the punch mark is 31.42, and we need to use 31.42 times 2 and then we will get 62.84. So 85 minus 62.84 divided by 62.84 times 100, and then we will get the value for percentage elongation. So we will get 35.26 is the final answer for percentage elongation. Next is percentage reduction in area. The formula for reduction is AO minus final area divided by AO times 100. So after calculating, we will get the percentage reduction in area is 62.41. After that, we need to check our answer to see if it is accurate or not. So this is my final calculation, my final result for my tensile test on mile scale. So that is all from me. Thank you for watching.